that is left hand derivative at x equal to 0 r f dash 0 are finite and equal. Now, to prove this result, we have got dy dx equal to this one. Number 7, we have to find the coordinates of the point lying on this curve y equal to 1 plus 2x minus 3x square, where the tangent drawn makes 45-degree angle with the positive direction of x-axis. As per sum, since the tangent is making angle 45 degrees, therefore tan psi is equal to tan 45 degree, that is 1. Therefore, dy dx, tan psi is the slope of the tangent to the curve. Therefore, dy dx, that is equal to 1. dy dx, that means ddx of this one, 1 plus 2x minus 3x square is equal to 1, or ddx 1 plus ddx 2x minus ddx 3x square is equal to 1. Therefore, this is 0, 0, this is 2 minus 6x equal to 1, or 6x equal to 2 minus 1, that is 1. Therefore, x equal to 1 by 6. Now, we have got the value of x. Now, if we put this value here, therefore, y when x equal to 1 by 6 is equal to 1 plus 2 into 1 by 6 minus 3 into x square means 1 by 6, 1 by 36. Now we simplify. One plus 1 by 3, that is 4 by 3, minus 1 by 12. We calculate that. Minus 1, 15 by 12 by 4. Therefore, I write here or here. Therefore, coordinates of the point on the given curve where the tangent makes 45 degree with the x-axis, with the positive direction of x-axis, or we simply say with the x-axis is same. Or 1 by 6, 5 by 4. Therefore, the sum is solved. I repeat, given curve is this one, we have found dy dx. Since the tangent makes angle 45 degree with the x-axis, that means tan psi is equal to tan 45 degree is equal to 1. That means dy dx equal to 1. I have used that and got the value of x. Now for getting the value of y, we have to put this value here, and I have put the value and obtained this value. Therefore, coordinates of the point on this curve where the tangent drawn will make angle 45 degree with the x-axis is this one. Therefore, the sum is solved. Now, this one. V is given. Already I have discussed that acceleration is rate of change of velocity, that is dv dt. Therefore, to solve this sum, first we find dv dt. Therefore, dv dt is equal to d dt 60 square minus 2t cube, that is equal to d dt 60 square minus d dt 2t cube, that is equal to, this will be 12t minus 6t square. Derivative of 6t square with respect to t, 6 is constant outside, d dt of t square, that is 2t, therefore finally 12t. Then d dt of 2 cube, 2 is constant taken outside, 2 into d dt of t cube, d dt of t cube is equal to 3t square. Therefore finally this one. Therefore acceleration of the particle at t equal to 4 second is equal to dv dt t equal to 4s. Now we have to put the value here, 12 into 4 minus 6 into 4 square means 16, that is equal to 48 minus 96, that is minus 48. Now since acceleration, we have to put proper unit. Here unit of time is not mentioned, just we write here unit length per second square. Unit of acceleration is unit distance by unit time square. That is why I have written like this. Therefore, this sum is solved. Now, I have worked out so many sums on application of derivatives. Actually, more detailed matter will be discussed in the second part. Actually, that is discussed in class 12. That means part 2, when I shall discuss those detailed matters will be discussed. Now I work out few more sums on derivatives. Few more. Though I have worked out many sums on derivatives. I think few more sums are to be solved for you, so that you will be skilled enough. Now I am going to working out few more sums on derivatives. I have written already sums on the board. Now I work out one by one. First of all, number 1. Fx is defined like this. We have to show that fx is differentiable at x equal to 0. First we write down the condition. Fx will be differentiable at x equal to 0 if dash 0, that is left hand derivative at x equal to 0, or f dash 0 are finite and equal. Now f dash 0 is equal to limit h tends to 0 if 0 plus h minus f 0 by h. Therefore, L f dash 0 is equal to limit h tends to 0 minus f h minus f0 by h. Left hand derivative. For derivative, this is as per definition. Now left handed derivative, h tends to 0 minus f0 plus h means fh here. Therefore, h is negative. For x not equal to 0, fx is defined by this. Therefore, we can write here one by h sine a square f0 as per definition 0 by h, that is equal to limit h tends to 0 minus 1 by a square sine of a square. H is very small, therefore limit a square tends to 0 sine of a square by a square. Considering a square a new variable say k, limit k tends to 0 sine k by k, that is standard limit form, that will be equal to 1. Now for r f dash 0 also, here h tends to 0 plus. Similarly, r f dash 0 will be equal to limit h tends to 0 plus sine of a square by a square, that will be equal to 1. Therefore, L f dash 0 is equal to r f dash 0. We note both are finite and equal. Therefore, we conclude f is differentiable. here. Therefore, fx is differentiable at x equal to 0, and already we have calculated f dash 0 is equal to 1. Therefore, the first sum is solved. Now, I think you have followed, the students were following, and already I have advised that while you are following these classes, you work out the sums which we are or I am discussing here yourself and follow the steps. Now sum number 2. For that I rub this one. Given y is equal to 1 plus x square by factorial 2 plus x cube by factorial 3 plus x to the power n by factorial n. One thing I have not discussed yet, the factorial symbol. Just I discuss here. Factorial n that is equal to product of 1, 2, 3 dot 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 up to n. Also we can write in reverse order, n into n minus 1 this is the meaning. From this it is clear that factorial of negative number or fraction is not possible. Actually, in case of natural number, we take this definition also. By definition, factorial 0. The other symbol of factorial is n factorial, also written by this symbol. Now this sum dy dx is equal to ddx by applying that addition law or sum law. Ddx of u plus v equal to du dx plus dv dx. I write here, skipping that step. Ddx of 1 is 0, ddx of x is 1, then ddx of x square by factorial 2, that means 2x by factorial 2 means 2, then 3x square by factorial 3 is there, that is 3 into 2 into 1, then 4x cube, 4 into 3 into 2 into 1 plus this will be n x to the power n minus 1, then this is n into factorial n minus 1. Therefore, after simplification, it will be 1 plus x plus you see x square by 2 plus x cube, 4 cancelled, this is factorial 3 plus n cancelled, x to the power n minus 1 by factorial n minus 1. Therefore, 1 plus x square 2 factorial is equal to 2. Therefore, I can write this factorial 2 x cube by factorial 3 plus x to the power n minus 1 by factorial n minus 1. Here I have used one thing, you see, factorial n, that is equal to n into n minus 1 into n minus 2, 3 to 1. Now, this product is nothing but factorial n minus 1. Therefore, factorial n is equal to n into factorial n minus 1. Now, to prove this result, we have got dy dx equal to this one. Therefore, if I add this one, x to the power n by factorial n, what we get on the right side, 1 plus x square by factorial 2 plus x cube by factorial 3 plus x to the power n minus 1 by factorial n minus 1 plus x to the power n by factorial n. Now, as per this information, this is y, that is equal to y. Therefore, dy dx final step is this, plus x to the power n by factorial n is equal to y. Proved. Then sum number 3. Up to n terms in the earlier one, and here it is to infinity. That means here we have to mention. Now I take the help of this one. Number 3, it will be to infinity we can write also like this. Therefore, for this step, we can write therefore dy dx is equal to this. Therefore, after simplification, it will be 1 plus x square by 2 plus x cube by 3 factorial plus 2 to infinity. Therefore, finally dy dx will be to infinity. If we don't mention this symbol to infinity, meaning is same. Therefore, dy dx, what we get? This one. First y equal to this one, we differentiate it, and after simplification we get this one, and finally this one, and this is nothing but this y. Therefore, which is equal to y dy dx equal to y. This number 3 sum is similar to number 2, therefore I have worked out like this. Now sum number 4. If x is derivable at x equal to a, as per sum if dash a exists and if dash a equal to limit x tends to a fx minus fa by x minus a. Already we have discussed it earlier. Now I shall use this to calculate this one. LHS is equal to limit x tends to 1 x fa minus a fx by x minus a. X tends to a, x tends to a, limit x tends to a. Now I write this expression like this: x minus a whole into fa. Actually the denominator is x minus a. Keeping that in mind, I have written this first part like this. Now a fa, that is written in excess. For balancing it will be a fa minus a fx, the whole divided by x minus a. Now I write here limit x tends to a x minus a whole into fa by x minus a, plus here a is common factor, f a minus fx x minus a. Now these two are cancelled since x is not equal to a. Therefore from this I get fa. Here x is variable, x tends to a, but there is no x, that means fa is constant, therefore the value will be fa. Now I take minus common, minus a into limit x tends to a fx minus fa by x minus a. Therefore this is fa minus, and already I have written f dash a equal to this one. Therefore this is f dash a. Therefore I can write the final step like this: limit, or write RHS. Already I started from LHS part and got the right hand side part, fa minus a f dash a. Therefore the sum is solved. Therefore, learner or students, I have finished the first part of derivative. Also I have discussed application of derivative, and the later part, that is different rules of finding derivatives for other forms of given function, will be discussed in the part 2 or later part, as well as second order derivative or more order derivatives, also application of calculus, that is meant for class 12 syllabus.